The aim of the experiment is to test the Earth's gravitational acceleration through a simple pendulum, which is a system consisting of a mass hanging from a thread of negligible mass attached to a support. Separating the pendulum from its equilibrium position, it will start to oscillate. Therefore, through the period of oscillation of the pendulum, it is possible to check the acceleration of gravity depending on where it is found.
In this video, we're going to try to explain how Newton discovered gravity's value. For that, we have to understand that gravity is a mutual force between two bodies that has a determined mass. Newton arrived to that discovery by the utilization and observation of the acceleration with which an object falls, and it changes according to the body with which it is measured. All of this takes part of the famous gravitational acceleration law, and the classical explanation is that heavier bodies are proportionally more difficult to accelerate.
After assembling the pendulum, we will measure how much time does it take for the pendulum to achieve 30 oscillations. After that, we will divide that time by 30 in order to get the time of one oscillation. That data we will substitute in our equation and finally achieve the value of gravity. Project, we learned that in physics and in general, it is often easier to propose the theoretical problem and solve it in this way, being accurate, than proposing it and taking it to practice. But we're happy that it worked, and not the first time it worked, but at the end it gave us the results. The limitations of the experiment basically relied on two things. The first, the repetition that we measured was inaccurate, and the height to which the weight was lifted altered the results. Results were as expected because we did put into practice the way it should be done. The objective was to give out the gravity, and it take out a value very close, so our experiment was very accurate.